Hello dear students, welcome back. So already we are discussing the level 1 questions, NEET level questions in chemical bonding. So in first video we have discussed around 52 questions, I think so. So from the 53rd question, so without wasting any time, I'm going to start. Okay, 53rd question. Okay, PO4 3 minus. What is the formal charge on each oxygen atom and the bond order respectively? Okay, PO4. So phosphorus has 5 valence electrons. 1, 2, 3, 4, 5. Then oxygen has 6 electrons, valence electrons, 1, 2, 3, 4, 5, 6. So there is a double bond here. Single bond oxygen, single bond oxygen, single bond oxygen. Phosphorus to the maximum can bond these 5 bonds. In the oxygen மேலே ஒரு மைனஸ் இருக்கு, இது மேலே ஒரு மைனஸ் இருக்கு, இது மேலே ஒரு மைனஸ் இருக்கு. That is why it is called as PO4 3 minus. PO4 3 minus. Okay. So in total there are 4 oxygen atoms. What is the total charge on 4 oxygen atoms? Sir, all the 4 oxygen atoms in collective has minus 3 charge, sir. What is the charge on 4 oxygen atoms? Minus 3. What is the charge on only 1 oxygen atom? Only 1 oxygen atom. Sir, x is nothing but cross multiplication. Therefore, x is equal to minus 3 by 4. So, the charge on only 1 oxygen atom is minus 0.75. So, your answer is any one among the 3. So, the formal charge on an oxygen is minus 0.75. Then, bond order. So, what is the formula for bond order? In spite of structures having resonance, இந்த மாதிரி resonance இருக்கிற structuresல bond orderக்கு என்ன formula சொல்லி கொடுத்துருக்கோம்? Number of bonds by number of resonating structures. So number of bonds by number of resonating structures. சரி, ஸோ இங்கே மொத்தம் எத்தனை பாண்ட் இருக்கு பாருங்க சார். 1, 2, 3, 4, 5 5 பாண்ட் இருக்குது சார். இப்போ எத்தனை ஸ்ட்ரக்சர்ஸ் இதெல்லாம் சார்? இந்த ஆக்சிஜன் கிட்ட டபுள் பாண்ட் போட்டிருக்கோம் ஒரு ஸ்ட்ரக்சர். இஃப் வி புட் எ டபுள் பாண்ட் ஹியர், செகண்ட் ஸ்ட்ரக்சர். இஃப் வி புட் எ டபுள் பாண்ட் ஹியர், தேர்ட் ஸ்ட்ரக்சர். இஃப் வி புட் எ டபுள் பாண்ட் ஹியர், ஃபோர்த் ஸ்ட்ரக்சர். ஸோ ஐ கேன் ரைட் 4 different structures. ஸோ 5 by 4, the answer is 1.25. The answer is 1.25. So the answer for the question is option C. 54. The correct order of increasing bond length. Okay. They have given carbon monoxide, carbonate, CO3 2 minus. This is carbonate, carbon dioxide. Okay. In the morning, they are asking bond length. Right. This is exactly triple bond. This is exactly triple bond. Triple bond means bond order 3. On both sides, exactly double bond. Double bond means bond order 2. Bond order 2. Here, what is the bond order? Sir, just now we saw the formula. Bond order is equal to number of bonds, 4 bonds, by 3 resonating structures. It is 1.33. 1.33. So, triple bond தான் இருக்கிறதுல சின்ன பாண்டாக இருக்கும் இல்லையா? ஸோ அப்போ பாண்ட் ஆர்டர் அதிகமாக இருந்தால் பாண்ட் லென்த்து ரொம்ப கம்மி. they are inversely related to each other. அப்போ இருக்கிறதுலையே பாண்ட் ஆர்டர் 3ன்றதுனால இதுக்கு தான் ரொம்ப கம்மி. பாண்ட் லென்த் ரொம்ப கம்மி. பாண்ட் ஆர்டர் 3, பாண்ட் லென்த் ரொம்ப கம்மி. அப்போ பாண்ட் ஆர்டர் யாருக்கு ரொம்ப கம்மி? CO3 2 minus. அதுதான் பாண்ட் லென்த் அதிகமாக இருக்கும். நான் CO2 in between. ஸோ பாண்ட் ஆர்டர் பாருங்கள், இதுக்கு 3, இதுக்கு 2, இதுக்கு 1.33. அதனால் பாண்ட் லென்த்து increases in this direction, exactly opposite to bond order. So இந்த கொஷனுக்கான ஆன்சர் ஆப்ஷன் 4. 55. பாருங்கள், the group of substances in which melting point covalent bond breaks up. இங்கே ஒரு கமா போட்டுக்கும். ஸோ எந்தெந்த சப்ஸ்டன்ஸ்க்கெலாம் மெல்டிங் பாயிண்டில் கோவேலண்ட் பாண்டு பிரேக் ஆகும்? சரி, மெல்டிங் பாயிண்ட். சரி, இந்த காம்பவுண்டில் எல்லாத்துலேயுமே பாருங்கள் அயானிக் காம்பவுண்ட்ஸ். இது எல்லாமே அயானிக் காம்பவுண்ட்ஸ். ஓகே, இங்கே வாங்க. சாலிட் அயோடின் சப்ளிமேட், இது டைரக்ட்லி கன்வெர்ட்ஸ் இன்டு வேப்பர். இதெல்லாம் மெல்ட்டே ஆகாது, லிக்விட் ஸ்டேட்டுக்கே போகாது, டைரெக்டாக வேப்பர் ஸ்டேட்டுக்கு தான் போகும். ஸோ அப்போ இந்த கொஷனுக்கான ஆன்சர் கண்டிப்பாக ஆப்ஷன் 3 தான். ஏன் சார், இந்த எக்ஸாம்பிள் ஆப்ஷன் 3ல் கொடுத்துருக்கிறது எல்லாருமே கோவேலண்ட் காம்பவுண்ட்ஸ். கம்ப்ளீட்டாக மூணுமே பாருங்கள் பக்கா கோவேலண்ட் காம்பவுண்ட்ஸ். மெல்ட் ஆகுதுன்னு சொன்னாலே உருகுது, மோல்டன் ஸ்டேட்டில் பாண்டு பிரேக் ஆகுது. இங்கே இருக்கிற பாண்டு எல்லாமே என்ன பாண்டு? கோவேலண்ட் பாண்ட். என்ன பாண்ட்? எல்லாமே கோவேலண்ட் பாண்ட். ஸோ அப்போ கோவேலண்ட் பாண்ட் எங்கே பிரேக் ஆகுது, மெல்ட் ஆகும்போதுனா ஆப்ஷன் 3. நெக்ஸ்ட், in which of the following compounds ionic and covalent bonds both are present? Both are present. இங்கே K plus Cl minus ionic bond, sulfur dioxide covalent bond, methane 4 covalent bonds, Na plus OH minus. In this oxygen and hydrogen are having covalent bond. நல்லா கவனி, Na plus OH minus இதுதான். And the bond between these two is ionic and this is a covalent bond. This is a covalent bond. Question number 57. Solid methane. So this is a methane and this is a methane. They are nearly touching each other because solids are very tightly packed. அப்போ ஒரு மீத்தேனுக்கு இன்னொரு மீத்தேனுக்கு what is the force between them? If it is a metal we can say metallic bond. If it is a metal we can say metallic bond. What is the force? If it is an atom and if it is an atom we can say covalent bond, covalent solid அப்படின்னு சொல்லலாம், right? But here there is no other, no ionic, no charge is there, no covalent bond is there. So this is simply called as a molecular solid. It is a molecule. It is A is a molecule and B is another molecule. Both of them are methane. So this solid is called as molecular solid. Molecular solid. Question number 58. Which of the following compound has the weakest bond? Diamond, strongest, hardest substance. Hardest substance. Very strong covalent bond. Ionic bonds are comparatively stronger bonds. Dipole force in between one water molecule and another one water molecule. Dipole force. Whereas this is simply Van der Waals force. Van der Waals force. So which is the weakest bond? The one which is present in neon solid. 59. The species having zero dipole moment. Zero dipole moment. First one, xenon tetrafluoride. Xenon has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. Sir, this is square planar geometry, sir. And the electron pull by this fluorine is cancelled by this. The electron pull by this fluorine is cancelled by this. And the electron pull by this lone pair is cancelled by exactly opposite lone pair. Every vector cancel each other. So the dipole moment value of this substance is 0. Remaining all others, they do not have zero dipole moment. You just discuss them, okay? Right. Question number 60. What conclusion can be drawn from the fact that BF3, the dipole moment of BF3 is equal to 0, but the dipole moment of PF3 is not equal to 0. Right. My question is whether the bonds here is polar covalent bond or non-polar covalent bond. Sir, they are all polar covalent bond. Here also polar covalent bond. What is a polar covalent bond, non-polar covalent bond? Sir, if the bond is formed between same person, hydrogen and hydrogen, this is called as non-polar, no charge, non-polar, charge illada covalent bond. If the bond is formed between A with B, anyone, any other person, it is called as a polar covalent bond. So, example, this compound is having polar covalent bonds, but the dipole moment is 0 because the vectors cancel each other. So, அப்போ இங்கே பாருங்கள், boron trifluoride. We know the structure of boron trifluoride. It is trigonal planar. So, this vector and this vector, they act in a particular direction where this will be the resultant vector. And there is a vector which is exactly opposite to it. So this vector quantity cancels this vector quantity. So the dipole moment of the molecule is 0. So whereas in PF3, Phosphorus is having 5 valence electrons. 1, 2. Third, fourth, fifth valence electron. So here there will be very low value, that is it is not equal to 0, but there will be a very minimum value, but it will not be equal to 0. So what is the conclusion? BF3 is not symmetric. This is wrong. Linear, wrong. Atomic radius of phosphorus doesn't play any role here. So the BF3 must be triangular planar. Very good. Option D is your answer. Option D is your answer. Question number 61. Decreasing order of dipole moment. Decreasing order. Okay. So this fellow is a group who is an electron donating group. Okay. This fellow is a group who is electron withdrawing group. And see here, this fellow is donating and this fellow is withdrawing. So there is more electron shift in this molecule. In this molecule, there is more electron shift. So C is having the greatest dipole moment. C is having the greatest dipole moment. Right. Now, come here. Among the two, the pulling power, electron withdrawing ability of this group is very high. So B will be having a more dipole moment than A. Listen carefully. Nobody is having 0. This is not equal to 0. This dipole moment is not equal to 0. And this dipole moment is also not equal to 0. But we are comparing the values. In the 3 பேர்ல dipole moment யாருக்கு அதிகமா இருக்கும்? Who will be having greater dipole moment? C. Then B. Then A. So your answer is option C. PCl5 is non-polar. Why? Sir, phosphorus is having 5 bond pairs around it. This is PCl3 and this is the chlorine above it and this is the chlorine below it. Listen carefully, pa. This fellow pulls the electron in this direction and this fellow will pull the electron in this direction, and the resultant vector will be acting here. There is an exact opposite vector, so they cancel each other. And similarly, this upper bond, axial bond, is cancelled by the opposite one. So each and every vector cancel each other. So the dipole moment of this molecule is 0. Dipole moment of this molecule is 0. They have polar covalent bonds. They have polar covalent bonds, but dipole moment equal to 0. So the answer for the question is PCl bond is non-polar. Wrong. Yeah, option 2. Option 2. 63. The dipole moment is highest. Okay. These are all symmetrical molecules. The dipole moment for this fellow is 0 and the dipole moment for this fellow is also 0. So coming for A and C. Sir, 1 chlorine, 2nd chlorine, 3rd chlorine, only 1 hydrogen is there. Fluorine. 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 3rd one, hydrogen. So this is also pakka tetrahedral structure and this is also pakka tetrahedral structure. So the electrons are pulled in these 3 directions, whereas this fellow is donating electron. Because among carbon and hydrogen, carbon is more electronegative. So the dipole moment is not equal to 0. There will be a value. Here also the same thing. Dipole moment is not equal to 0. Who is having the highest value? Sir, both, since geometry is same, arrangements are same, we have to look at the electronegativity. So the electronegativity, when comparing chlorine, fluorine is greater electronegativity. So this molecule will be having a greater dipole moment. This molecule will be having a greater dipole moment. Question number 64. Linus Pauling received Nobel Prize for his work on which one? Linus Pauling worked a lot in chemical bonding. Okay, wow. Regarding chemical bonding, he determined the hybridization of molecules and something like that. Right. 65. Dipole moment of carbon dioxide is 0. What do you understand, sir? The structure of carbon dioxide is CO2 this much. Dipole moment mu equal to 0. That means this vector electron pulled by this oxygen is exactly cancelled by another oxygen. So the molecule is linear. If there are 3 bond pairs, not trigonal planar. But since there are only 2 bond pairs, according to VSEPA theory, the molecule is a linear molecule. The molecule is a linear molecule. Question number 66. Which of the following contains both polar and non-polar bonds? Polar and non-polar bonds. Both should be present. It contains ionic bond. So that is not going to be the answer. HCN. This is also polar. Polar. This is also polar. Polar means charge is there. Because if the bond is between A, it is called as non-polar. If the bond is between A and any other person, it is polar. Okay? Going for the third one, hydrogen peroxide, open book structure. This is the structure of hydrogen peroxide. This bond is non-polar. Why? It is in between both same oxygens. It is polar. So who is containing polar as well as non-polar bonds? Hydrogen peroxide. Hydrogen peroxide. Question number 67. The correct order of dipole moment. What are the molecules given? CH4, NF3, NH3, H2O. Right. Sir, how to answer this question? Very easy. This is a symmetrical molecule with tetrahedral, proper tetrahedral arrangement. So the vectors cancel each other, mu value is equal to 0. Look at all these three fellows. This is NF3. This is NH3. This is bent structure, OH2. So, you just look and answer me. Sir, in first structure, these three fellows are dragging the electrons towards downward direction. And there is a person who is dragging the electrons towards upward direction. So, anyway, mu is not equal to 0. There will be dipole moment. But for this case, mu equal to 0. Okay. Here, sir, among these two, hydrogen will push the electron. So, three fellows are pushing electron and one fellow is dragging it. So, the more shift towards here, more shift towards top. So, more negative on the top side. Sir, mu value is not equal to 0, but it is greater. Mu value is greater. So, when comparing NF3, NH3 will be having a greater dipole moment. Simply, I will explain this like a repaired car. Nalla gavani. Consider nitrogen as a repaired car. Okay? Both the nitrogens. A repaired car. Three persons are pushing the car in this direction and one person is pulling the car in this direction. The car will move faster. That means more electron shift towards the top side. More electron shift. More negative here means more positive at the bottom. Okay, ba? Whereas here, see, three persons are dragging the car in this direction. Moonu per car keezhe edukranga and one person is pulling the car in this direction. The car will move. Who is more powerful? Keezhe edukranga more powerful. The car will move. But the separation of charge will be less. Plus minus kammiya irukum. Right. Whereas here, more pulling on the top and these fellows are pushing. The car will move very, very faster. So, water value will be very, very high. And this is very, very low is because this is 0. This is 0. So, the exact answer for the question is water should be the highest, methane should be the lowest, and NF3, NH3, yeah, order A. Order A. 68th question. The valence shell electron pair repulsion theory based questions. Okay. Among the following species, identify the isostructural pairs. Who are all isostructural? How to determine the structure? Right. So, we will go for one by one. Anyway, we have to find for everyone. NF3. Sir, nitrogen has 5 electrons. Out of the 5 electrons, 3 electrons are in bond and 1 lone pair. 5 electrons per nitrogen. 1, 2, 3 electrons in bond, 4th and 5th. So, 3 bond pair, 1 lone pair means what structure? Pyramidal. Okay. Then NO3 minus. Sir, nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. So, this is a double bond formed to an oxygen. This is a coordinate bond formed to an oxygen. And this is a bond formed to oxygen who is carrying a minus charge. So, Lewis theory. So, you know how to draw the structure by using Lewis theory. So, see here, around nitrogen, how many pairs? This is a pair. According to VSEPA3, this is one pair. This is second pair and this is third pair. So, there are 3 pairs of electrons. 3 bond pairs. 0 lone pairs. So, this is trigonal planar. Trigonal planar. Then, BF3. Sir, boron has 3 valence electrons. So the 3 electrons are shared for 3 fluorine atoms. So exactly 3 bond pair, 0 lone pair. So it is also trigonal planar. Then H3O plus. Sir, oxygen. This is water molecule, sir. If these electrons are given to another hydrogen, it becomes plus charge because oxygen has donated its electron. Now, around oxygen, 1, 2, 3 bond pairs and 1 lone pair. 3 bond pair, 1 lone pair, it is pyramidal. Right. The last one, HN3. This is nothing but, we can write this as N3 minus. So, so we have to write the structure like, so in total there will be a minus charge. This is called as N3H, right? So this is linear in straight chain. Okay, so now think of who are all isostructural, NO3 minus and BF3. So the answer may be this or this. And NF3 with H3O plus. So NF3 with H3O plus. So the answer for the question is option C. 68th question answer is option C. Going for 69. The shape of sulfate ion. What is sulfate? It is nothing but SO4 2 minus. SO4 2 minus. Sulfur has 6 valence electrons. 1 towards this oxygen, 2 towards this oxygen, 3, 4, 5, 6. So this may be a double bond or a coordinate bond, whomsoever it may be, don't worry about this. But these two fellows will be carrying a negative charge. So this is called SO4 2 minus. So around the sulfur, how many bond pairs? Sir, this is a bond pair. This is second bond pair. This is third bond pair and this is fourth bond pair. So there are 4 bond pairs and 0 lone pair because sulfur has donated all of its electron. So 4 bond pairs and 0 lone pair means it is pakka tetrahedral, sir. Pakka tetrahedral, sir. So the answer for the question is option B. Question number 70. In which of the following compound have linear geometry? Which one is having linear geometry? Okay. This is tetrahedral, so this is not going to be your answer because methane is carbon pakka tetrahedral arrangement. Then going for option C, NO2 plus, nitrogen is having 5 valence electron. 1, 2, 3, 4. There is no 5th electron, that is why it is positively charged. This one is a double bond O and this one may be a double bond or a lone pair. So this is linear. Carbon dioxide CO2 is linear. XeF2, xenon is having 3 lone pairs. These are 3 lone pairs of xenon. Trigonal, bipyramidal, மேல ஒன்று கீழே ஒன்று F2. So this is geometry, trigonal bipyramidal geometry. Whereas when coming for structure, you have to think of only this straight line which is nothing but linear. So xenon has 8 valence electrons. Where are the 8? 1, 2, 3, 4, 5, 6, 7th one in this bond and 8th one in this bond. So out of the 8 electrons, 3 electrons are present as lone pairs. So leave the 3 lone pairs and think of xenon is here, one fluorine is here, another fluorine is here. It is also linear. So the answer for the question is option C. 70th question is option C. Right. Look at, there is some mistake here. There is no molecule like this. Okay, there is some mistake. We'll go for question option 4. This is trigonal planar, Trigonal planar, no geometry, no linear. This is tetrahedral, linear kadayadu. So the only possibility answer is option C. Linear geometry. Okay. Next. Question number 71. Which of the following order of decreasing bond angle is correct? So we have to think of the bond angles of CaCl4, BF3 and NO2 plus. This is tetrahedral, this is trigonal planar and this is linear. Just now I told you, here it is. Yeah, this is linear. Tetrahedral means 109 degree, trigonal planar means 120 degree, linear means 180 degree. So among the 3, the one having the greatest bond is this fellow. So the given order is wrong. Next, come here. NH3, NCl3, NBr3. In all the of bonded atom decides the angle. If the size of the bonded atom is greater, bond angle is also greater. So, among hydrogen, chlorine and bromine, who is bigger in size? Bromine is bigger in size. So, this bond angle will be very, very greater. But it is given wrongly. So, this is not your answer. So, A is not your answer. B is not your answer. Going for C. Sir, OBr. 2 lone pairs. OCl, again 2 lone pairs. OF, again 2 lone pairs. So 2 lone pairs are same in all the cases. Don't worry about the lone pairs. Think of, just now I told you, same central atom. That means if the size of the bonded atom is greater, bond angle will be greater. So among bromine, chlorine, fluorine, who is bigger in size? Bromine is bigger in size, so this bond angle will be greater. So it is accordingly given. So the answer for the question is option C. Fluorine is very small in size, so the bond angle will be comparatively, among the 3 angles, this will be smaller angle. This will be a smaller angle. So the answer for the question is option C. 72. Which is not correct. Okay. SO3. Yeah. Coordinate bond is there. Ozone, coordinate bond is there. Ammonia, NH3. This nitrogen is giving its electron to hydrogen. That is by coordinate bond. So this is correct. Option A is given correct. Option B. This is bent. Very good. NO2 is bent. Very good. Cl2 minus is also bent. They are all V-shaped molecules. This is also given correct. If you don't know, go through the VSEPR theory. Then next, I3 minus. Instead of 2 iodines, there are chlorines, halogen, same molecule. NO2 plus just now we saw, all these 3 are linear. This is also correct. Because we have practiced this a lot of times. Right. Going for question number 4. SF4 is tetrahedral. It itself is wrong. SF4. Sir, sulfur is having 6 valence electrons. 2, 3 here, 4th one here, 5th one on the top and 6th one on the bottom. This is SF4. It is seesaw shaped. Seesaw in shape, but it is given tetrahedral. So definitely this statement is wrong statement, and they are asking you which is not correct. So option D is not correct. Question number 73. The shape of a molecule having 4 bond pairs and 2 lone pairs. 4 bond pair, 2 lone pair. In total 6 pairs. So what will be the shape? Sir, in total 6. Geometry is octahedral. 1 lone pair is there, square pyramidal. 2 lone pairs are there, it is square planar. Okay? Right. Question number 74. The hybridization of XeOF2 and XeO2F2 is sp3d. But the shape will be, what will be the shape? Listen carefully. Xenon, first structure. Sir, oxygen, there is only 1 oxygen and 2 fluorines. So, oxygen requires 2 electrons. Sir, okay sir. Fluorine requires 1 electron. So, this is okay. Triangular like structure. Okay, now I am linking up xenon. Sir, 1 electron, 2 electron, 3rd electron, 4th electron. The 5th one and 6th one, 7th one and 8th one are lone pairs. So, xenon is having here 3 bond pairs and 2 lone pairs according to VSEPR theory. 3 bond pairs and 2 lone pairs. I'll show you where are the bond pairs. This is 1 bond pair, this is 2nd bond pair, and this is 3rd bond pair. So, 3 bond pairs and 2 lone pairs. That means, though it is having sp3d hybridization, this molecule is seesaw shaped. Sorry. 4 bond pairs not seesaw shaped. It is T shaped. Sorry, it is T shaped. Capital letter T. Capital letter T. So the diagram which I have drawn itself is wrong. So anyway, I'll draw the exact structure. Xenon O F. This is one lone pair and this is another lone pair. So this is exactly T shaped. Then XeO2F2. XeO2F2. So xenon is having, I'll simply make out of the 8 electrons, 2 electrons, 2 electrons, fifth one, sixth one, 7 and 8. Think of xenon is having 8 valence electron, right? Where are those 8? 1 here, 2, 3, 4, 5, 6, 7 and 8. So around xenon, there are 4 bond pairs and 1 lone pair. 4 bond pair and 1 lone pair means, just now I told you, it is seesaw shaped. It is seesaw shaped. So what will be the answer for the question? Sir, the first fellow is T shaped. The second fellow is seesaw shaped. First fellow T shaped. So your answer should be A, B or D. A, B or D. Whether the second one is V shaped, no. Distorted trigonal pyramidal. Yeah, we can say it is distorted trigonal bipyramidal. Yeah, we can say this is distorted trigonal bipyramidal. Then what is the third one? It is T-shaped. Yeah, we cannot say it. Both are T-shaped. The second one is not T-shaped. It can be called as distorted bipyramidal. So the most appropriate answer for the question is option B. Option B. Next, 75. IF4 plus. Gavani. Listen, valence electron of iodine is 7. Plus charge means 1 electron less. That means here it is 6. Out of the 6 electrons, 4 electrons involved in bonding with 4 fluorine. And the 5th one and 6th one are present as 1 lone pair. 1 lone pair. So 4 bond pair and 1 lone pair means, just now we saw, it is seesaw. 4 bond pair and 1 lone pair means it is seesaw. Question number 76. In which of the following put a comma here, okay. Compound has 4 bond pair and 1 lone pair. 4 bond pair and lone pair. Listen, 4 bond pair. That means atom should be surrounded by 4 bonds. That means this fellow is having 4 valence electron. And 1 lone pair. That means M is having in total 6 valence electrons. The central person is having 6 valence electrons. Think here. Sir, nitrogen has 5 valence electron. There is a plus 1 charge. So I have removed an electron. That means here there are only 4 valence electrons. Iodine is having 7 valence electron. Out of that 4 electrons, minus means 1, 8 valence electrons. Here there are 8 valence electrons. Think of. Here there are 8 valence electrons. Simple. Sir, sulfur is having 6 valence electron. Xenon is having 8 valence electron. So the one which is having 6 valence electron is your answer. So the answer is option C. Otherwise, if you remember the structure, you can go sulfur, sir, 4 bond pair. Sulfur is having 4 bond pair. 1, 2, 3, 4. And the 5th and 6th electron are present as lone pairs. Seesaw shaped. So 4 bond pair or lone pair is around sulfur. Okay, ba? Right. Next. Question number 77. Each lone pair of electrons decreases the bond angle by about. So each lone pair decreases the bond angle by about. It is not exact, but in an approximation, we can say it is decreasing about some 2.3 or 2.4 degrees. So the answer may be B. Okay. I'm not exactly aware of this thing. Let it be. Let us do another one thing. Let us think of with an example. Methane, ammonia, water. The bond angle is exactly 109 tetrahedral, 107 degree. You know that. 104.5 degree. So what is the difference? Because there is 1 lone pair. Here 0 lone pair. Here 1 lone pair. Here 2 lone pairs. So 1 lone pair decreases by 2 degree and this is around 2.5 degree. So the answer will be around 2 to 2.5, in between 2 to 2.5. Question number 78. Which has pyramidal shape? Which has pyramidal shape? Pyramidal shape means we should go for 3 bond pair and 1 lone pair. 3 bond pair and 1 lone pair. Okay. Here there are only 3 bond pairs, so this is not the answer. Here there are 3 bond pairs and 1 lone pair. Yes. Yes, the answer is option B. 3 bond pairs and 1 lone pairs. So it is pyramidal in shape. 79. A sigma bonded molecule is T-shaped. T-shaped. The number of non-bonding pairs. The number of non-bonding pairs. Just now I told you, T-shaped means it arises from a trigonal bipyramidal geometry. So the central atom is here. So it is having this one lone pair and this one is second lone pair. So there will be around 2 lone pairs. There will be around 2 lone pairs. Question number 80. The regular geometry of XeO2F2. XeO2F2. Okay. Xenon. Out of 8 electrons, 2 electrons are used for 1 oxygen. Third and fourth for another oxygen. Fifth one, sixth one, seventh and eighth. So xenon is having 4 bond pair and 1 lone pair. Totally 5. 4 bond pair and 1 lone pair. Totally 5. So what is the geometry? Sir, geometry means totally 5 orbitals. sp3d means trigonal bipyramidal. Trigonal bipyramidal is the geometry. If they ask you the shape or structure, you should mention it is seesaw. You should mention it is seesaw. Whereas if they ask you the geometry, it is nothing but trigonal bipyramidal. Geometry is nothing but trigonal bipyramidal. Question number 80. The regular geometry. Geometry, they are asking you the geometry of XeO2F2. Oh, what is the previous one? Yeah. The same question. Oh, that's why I am getting confused. Yeah, both of them are same question. This is repeated. Leave it. Question number 81. Incorrect code regarding the shape. Which one is incorrect? Which one is incorrect? First one. Sir, N3 minus. Sometime few minutes before I wrote it is N3 minus. Hydrozoic acid. Okay. Then cyanide. We will usually write like this, but this carbon is sp carbon. sp carbon means it is linear. It will be like this. It will be like this. Linear. ICl2 minus. Sir, iodine has 7 valence electron. Minus means you have to add an electron, totally 8. Out of the 8 electron, 2 electrons is used for bonding with chlorine. 3, 4, 5, 6, 7, 8. So around iodine there are 3 bond pair, 2 lone pair. Sorry, exactly opposite. 2 bond pair, 3 lone pair. Such a molecule will be linear. So this is correct. Option A, whatever the thing they have given is correct. Going for option B, pyramidal. Pyramidal means 3 bond pair and 1 lone pair. Yes, there are 3 bond pairs and 1 minus lone pair. Yes, there are 3 bonds with hydrogen and 1 lone pair on nitrogen. Xenon O3, it is also pyramidal. How, sir? Xenon has 8 valence electron, 2 for 1 oxygen, 3rd and 4th, 5th and 6th for another oxygen, 7th and 8th as lone pair. So all the 3 are given correctly. So they are all pyramidal, correct. Third one, trigonal planar. First one is trigonal planar. Yes, there are only 3 bond pairs. Correct. Yeah, radical is also may be considered as trigonal planar. But anyway, this is not trigonal planar. Why? Just now I told you, see here. It is pyramidal. It is not trigonal planar. This is pyramidal. So the given things are not correct. So the answer for the question is option C. Option C. Question number 82. The non-planar species among the given structures. Okay. We have to go for the structure. This is, trigonal planar. CO3 2 minus. CO3 2 minus. This is exactly sp2. Trigonal planar. Right. Arsenic oxide anion. So what is the valence electron of arsenic? So it belongs to nitrogen family, 5 valence electron. 3 minus means you have to add 3 electron, in total 8. In total 8. Out of the 8 electrons, arsenic, out of the 8 electrons, 2, 4, 6. Oxide anion is non-planar. Now come for the third one, XeO3. Yeah, this is XeO3. Pyramidal shape, non-planar. So AsO3, 3 minus is non-planar. XeO3 is non-planar. Next, ClO3 minus. So sir, chlorine is having 7 valence electron. Minus means 8 electron. Out of the 8 electrons of chlorine, 2, 4, 6 electrons are used by oxygens. 7th one and 8th one. So this is also non-planar, sir. ClO3 minus is also non-planar. Next, BO3 minus. BO3 minus, sir. Boron is having 3 valence electrons. 1, 2, 3. This is BO3 minus. So this is planar, trigonal planar. BO3 3 minus is planar. Then SO3 2 minus. SO3 2 minus. Sulfur is having 6 valence electrons. 7th and 8th. The 2 minus charge means 7 and 8. 8 valence electron. Out of the 8 valence electron of sulfur, 2 is used for this oxygen. 3, 4, 5, 6, 7, 8. 2 is used for this oxygen. Let it be. So bent shape. It is not planar. Bent shape. So SO3. So whomsoever are non-planar. Sir, there are 4 species who are non-planar. They are nothing but ASO3 3 minus. Yeah, the first one. 82. 83. Valence bond theory. Which of the following is not an exception to octet rule? Which obeys octet rule? They are asking you which obeys octet rules. Here there are 6 valence electrons. No, it is not the answer. Beryllium has 4 valence electron. It is not the answer. Tin, carbon family. So tin is having exactly 4 plus 4. 8 valence electron. 8 valence electron. So the answer for the question is option B. The answer for the question is option B. Regarding ClO2, chlorine is having 7 valence electron. It is called as an odd electron species. 7 electrons, 2 electrons are used for one oxygen, 3rd and 4th for another oxygen. 5, 6, 7. There is a single electron, odd electron species. It is called as odd electron species. It is also not obeying the octet rule. So the one which is obeying the octet rule is tin chloride, tin 4 chloride. Question number 84. Which of the following pairs are electron deficient? Who are all electron deficient? Sir, option A. Why? Because option A, B2H6, it is called as diborane. It is called as diborane. And aluminium chloride. Aluminium has 3 valence electron. Aluminium has 3 valence electron. If you consider it as a covalent molecule, think of this is aluminium chloride. Because of Paget's rule, more polarization, more covalent character. There are 6 electrons around aluminium. So it is also not octet. Question number 85. Valency expresses generally total electron, no. Atomicity, no. Oxidation number, it is not exactly valency, but combining capacity. Valency means the combining capacity of an element. Listen carefully. The valency of nitrogen, with hydrogen is 3, but with oxygen is 5. How, sir? This is the compound and this is the compound. Okay? So, the charge of this fellow is -3. So, exactly -3, yeah. And the charge of this fellow is cross multiply. 5 for this fellow and 2 for this fellow. Plus 5. So, valency means how much it can combine with hydrogen is -3. How much it can combine with oxygen. So, valency means combining capacity. Question number 86. Which of the following element does not have valence equal to its group number. So the group number valency we can make. Group number valency. We can make a chart. Okay. So for sodium, what is the group number, sir? First group valency is also 1, sir. Super. Coming for aluminium, sir, the group number is 3. Third group valence is also 3, sir. Carbon group number is 4, valence is 4. So the answer for the question is oxygen. Group number, sir, group number is 6 because lithium, beryllium, boron, carbon, nitrogen, oxygen. This is first 1A, 2A, 3A, 4A, 5A, 6A. But the valency is in general minus 2. In general minus 2. So the one which does not have valency equal to its group number is oxygen. Among the given options, oxygen. Next, 87. Electronic configuration of a metal M is 1s2, 2s. So directly you write the metal, it is lithium. And a non-metal X is 1s2, 2s2, 2p3. Nothing but nitrogen. When they combine, lithium will be electropositive and nitrogen will be electronegative. So that 3 comes here and this one goes here. Li3n is the formula, that is M3X. M3X. So the answer for the question is option by 88. In N2H4, the type of overlapping present between N and H bonds. So listen. This is N2H4. Nitrogen is what hybridized? Sir, nitrogen here is surrounded by 3 bond pairs and 1 lone pair. 3 bond pair and 1 lone pair means total 4 pairs. That means sp3 hybridization. sp3 hybridization. Hydrogen has only 1s orbital. So the bond formed is between an sp3 orbital and an s orbital. So the answer is option C. Question number 89. The number of sigma bonds and pi bonds present in the compound. C triple bond N, C triple bond N, this is ethyl, CH2, CH3, and the one here is CO thrice. M, CO, CO, CO. So this is the structure of the molecule. This is the structure of the molecule. Right. I will check the pi bond first. It will be easy. Here there is a pi bond. 1, 2, pi in sigma. So let us see for the sigma bond. 3 sigma bonds. 3. 4th sigma bond, 5th sigma bond, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 sigma bonds. 19 sigma bonds. Coming for the pi bond. Here there is 1 pi bond. I will draw the pi bond in black. 1 pi bond, 2nd pi bond, 3rd pi bond, 4th pi bond, 5th pi bond, 6th one, 7th one, 8th one, 9th one, 10th one, 11th one. There are 11 pi bonds. So the answer for the question is option A. Option A. So it is 19 sigma bonds and 11 pi bonds. Option A. Okay. Question number 90. The boiling point of ICl is nearly 40 degrees Celsius higher than that of bromine. Okay. Although the two substances have relatively same molecular weight. Why? Why? Because it is called as interhalogen. Compounds formed in between halogens. This is simply halogen, bromine with bromine. This is pakka non-polar covalent bond. No charge is there. But this fellow is a polar covalent bond. Some charge is developed. So one molecule, one ICl, because of partial negative charge on chlorine, positive charge on iodine, another molecule, there will be very weak attractive forces between this minus and this plus. Because of polar molecule. ICl is a polar molecule. So the answer for the question is option C. Option C. Question number 91. Covalent bond is formed by. How a covalent bond is formed? Ions, no. Half-filled orbitals, maybe. Exchange of electrons, no. None, no. Yeah, it is by half-filled orbitals. Example, I will show you. This be a p orbital. It should be having an electron with clockwise, half-filled. This is another p orbital of anti clockwise rotation electron. So this is a half-filled orbital and this is another half-filled orbital. They combine and they form a sigma bond. So a covalent bond. Question number 92. The number of sigma bonds and pi bonds present in this molecule. First of all, write the molecule CH3, CH, double bond CH, C, triple bond CH. Sigma, third one, fourth one, fifth one, sixth one, seventh one, eighth, ninth, 10 sigma bonds. How many pi bonds? 1, 2, 3. 3 pi bonds. So 10 and 3. Option A. Question number 93. PP overlapping will be observed in which molecule? PP overlap. Sir, in hydrogen, S overlaps, that's sir, because it contains only NS, what's the 1s orbital? S orbital of hydrogen with bromine orbital. S orbital of hydrogen with chlorine orbital. So the answer is automatically very easy one, chlorine. How, sir? See, this is one chlorine, this is another chlorine. This is 3s2, 3p5. This is also 3s2, 3p5. If you need, I'll draw. Sorry. S orbital, p orbital. S orbital, p orbital. I'll draw this 3s2 and 3p5. Look at the screen carefully. 1, 2, 3, 4, 5. I'll draw here 3s2, 3p5. 1, 2, 3. No, it should be. Sorry, the eraser is not working. I'll draw the 5 electrons. 1, 2, 3, 4, 5. Now you think of this anti-clockwise electron and this clockwise electron. This belongs to a p orbital and this belongs to a p orbital. They overlap and form this bond. Okay, va? So the PP overlap is seen in Cl2, chlorine molecule. Chlorine molecule. Question number 94. Nitrogen does not form NF5 because, sir, nitrogen is a 1s2, 2s2, 2p3. Second shell, there are only 4 rooms. One room, second one, third one, fourth one. There is no vacant d orbital. So nitrogen can accommodate to the maximum 4 pair of electrons. Nitrogen cannot form fifth bond. There is no possibility for a fifth bond. So what is the reason? It contains no empty d orbital. Even there is no empty d orbital. Sir, why phosphorus can form 5 bonds? I will show you. Phosphorus is nothing but 3s2, 3p3, 3d0. It has got empty d orbitals. So what will happen? Look here. This is 3s2 and 3p3. Now phosphorus will send this electron here. Now phosphorus can have 5 unpaired electrons and it can form 5 bonds. Phosphorus can do it. Nitrogen cannot do 5 bonds, cannot form 5 bonds. Keep it in mind. 95. Which of the following compound of xenon is not possible? Which is not possible? Okay. So you think of xenon, 8 out of the 8 valence electron. Think of the first compound. 2 electrons are used in bonding. So 3, 4, 5, 6, 7, 8. Sir, 2 bond pair and 3 lone pair. Yeah, possible, sir. This molecule is possible linear geometry. We have studied geometry. Xenon. Sir, 1, 2, 3, 4 electrons are used for fluorine. 5th, 6th, 7th, 8th. So xenon is having 4 bond pairs and 2 lone pairs. In total 6. Sir, this is square planar. Yeah, we have seen this. XeF5. I have not seen such a molecule. Why? I will explain you. I will go for XeF6. Yeah, we have seen this molecule. This is sp3d3 distorted octahedron. Gavani. Listen. Xenon 1, 2, 3, 4, 5, 6 fluorine, 7th and 8th. So there are around xenon, there are 6 bond pairs, 1 lone pair, 7 pairs. This is called as distorted octahedral structure. 6 pairs means octahedron, 7th pair means distorted octahedron. Even this is also possible. Whereas XeF5 means xenon has to use 5 electrons for fluorine, 4th one, 5th one, 6, 7, 8. There is a single electron. This is not at all possible. This is not at all possible. Okay. Next. Bond length. Yeah, we have seen such a compound. Single bond, double bond, triple bond. Think of. Sir, bond order is 1, 2, 3. Bond order is inversely proportional to bond length. So the answer for the question is option 2. Very simple. Question number 97. Which of the following statement regarding covalent bond is not true? Which is false? They are asking you which is false. Electrons are shared. True. Non-directional. This is not true. They are in directional. That is what VSEPR theory tells us and we are studying it. They are directional in nature. Only ionic bonds are non-directional, because if a cation is here, it will attract the anion from any direction. So the not true statement is definitely option B. There is no other choice and no need for you to go for third option. Question number 98. In alene structure, the 3 carbon atoms are joined by allenes are nothing but C double bond C, and these 2 will be above and below the plane. A, B, C, Mn. So A, B, Mn are some molecules, some atoms, let it be. But these 3 carbons will be in a plane. They are joined by, the 3 carbon atoms are joined by 1 sigma and 1 pi bond here. 1 sigma and 1 pi bond here. So what is the big answer? They are joined by, if they ask you 2 carbon atoms means 1 sigma and 1 pi. They are asking you totally 3, all the 3. That means 2 sigma bonds and 2 pi bonds. 2 sigma bonds and 2 pi bonds. Question number 99. CO2 is a gas while SO2 is a solid. But both are. They are asking in a different way. CO2 is a gas. Because dipole moment equal to 0. Non-polar molecule. There is no attraction between one carbon dioxide and another carbon dioxide, so it exists as gas. Whereas silica is a polymeric substance. So instead of being like this, you may think similar to that of carbon dioxide. SiO2 will be like this. No, it will be a polymer. So this double bond goes to the right and the bond here goes to the top. Similarly, I am writing another silica. Likewise, it will go on polymeric structure. Okay. That's why it is a solid. Both are covalent molecule containing pi bond. No, there is no pi bond. There is only sigma bond. P pi, there is no pi bond. I just told you there is sigma bond. Both are acidic. Yeah, this term is correct because non-metal oxides are acidic. You know that very well, right? Carbon, silicon, both form acidic oxides. So, both are acidic in nature. Okay. Then, 100th question. Which of the following species does not exist? Yeah, it is a very easy question. I already told you. Like nitrogen, who is in the second period. Boron, carbon, nitrogen, oxygen, fluorine, they are all having 2s orbital and 2p orbital. So they can hold only how many pairs of electrons? 1 pair, second pair, third pair, fourth pair. They can have only 4 pair of electrons in their valence shell. Carbon cannot hold 6 pairs of electrons in its valence shell. Carbon cannot hold 6 pairs. Boron can hold 4 pair. Beryllium can hold 4 pair. Aluminium, he can hold more than 4 pairs because aluminium is a person who is below boron and this fellow is having 3s, 3p and 3d0, 3d empty d orbital. So he can hold more number of electrons. So the elements in second period cannot hold more than 4. So the answer for the question is option 4. So in this video 50 questions have been discussed, and again we have a lot of questions and will be discussed soon. So இன்னமும் questions நிறைய இருக்கு, டிஸ்கஸ் பண்ணிக்கிட்டே இருப்போம். Thank you. Thank you pa.